Hi, and welcome back to my channel, Learning Biology with Dr. Vanessa. In today's video, we are going to discuss blood clots. What are they? How do they form? And how do they dissolve? Disclaimer, the doctor in my name comes from the PhD I earned. I am not a medical doctor. My videos and content are for educational and informational purposes only. This is not to be used in lieu of medical advice, but to educate you. If you have a true medical emergency or issue, please see your physician. What is a blood clot? Blood clots form in areas where your blood thickens, which then forms a semi-solid mass. The process of blood clot formation can be triggered by an injury. This causes the blood clot to form in order to reduce blood loss. However, sometimes a blood clot can form inside vessels that are not injured. These loose clots can then travel through the blood and cause harm. In this video, we are going to take a look at how blood clots are formed. We will also go over the fibrinolytic system, which helps with the dissolution of these clots, even those that spontaneously form. Before we talk about blood clots, we need to talk about platelets. The main function of platelets is to form a plug to slow blood loss. The hormone thrombopoietin is what stimulates the production of platelets to be made. Myeloid stem cells develop into megakaryoplasts, and then megakaryoplasts turn into megakaryocytes. These very, very large cells, megakaryocytes, can then splinter off into 2,000 to 3,000 different fragments. These are what creates the platelets, these small little fragments of the megakaryocyte. These little fragments have many different vesicles inside of them that had developed as the megakaryocytes were developing. Even though they have all these vesicles within them, these little splinterings of the cells, platelets, have no nucleus. Because of this, they have a very short lifespan of about 5 to 9 days. The vesicles within the platelets contain blood clot promoting chemicals within them. Hemostasis, not to be confused with hematopoiesis, is the sequence of events that stops bleeding from a damaged blood vessel. The three mechanisms that reduce the loss of blood from vessels include vascular spasm, platelet plug formation, and blood clotting, also known as coagulation. Vascular spasm occurs immediately after blood vessels are damaged. This occurs by the smooth muscles within the vessels that contract due to the blood vessel being damaged. This contraction process can reduce blood loss for several minutes to several hours. By the vessel contracting, it can pull that vessel tighter and again help slow that blood loss through that injury. After vascular spasm, then platelet plug formation can occur. Platelet plug formation occurs in a series of steps. The first seen here is a platelet adhesion. Platelets are going to contact and stick to parts of the damaged blood vessel. This is due to signals being released once the blood vessel has been damaged. The second step of platelet plug formation includes the platelet release reaction. Once the platelets start to stick to the area of injury, these sticky platelets become activated. They begin extending many projections, and they liberate the contents of their vesicles. These contents include ADP, serotonin, and thromboxane A2. As the platelets release their contents, these contents make other platelets sticky and cause the platelets to gather together. Remember, these are in areas where blood is flowing, so there are plenty of platelets flowing by that can be made activated. This accumulation of platelets is the third step of the platelet release reaction and is referred to as platelet aggregation. As they come together more and more, they form what is known as a platelet plug. A platelet plug is pretty soft, made up just of all these platelets that have stuck together, and then, some red blood cells, some white blood cells can also become trapped within this platelet plug. But the platelet plug itself can stop blood loss completely if the hole in the vessel is not too large. Blood clotting occurs after the platelet plug has been formed. Blood clotting or coagulation is a series of chemical reactions that form fibrin thread. So even though we have a platelet plug that's already been made, it is not considered a blood clot until the fibrin thread has intertwined and formed around that blood clot, making it much stronger. Clotting is a complex cascade of enzymatic reactions that has two different pathways, the extrinsic pathway or the intrinsic pathway. The extrinsic pathway has fewer steps and occurs rapidly within seconds. This is because the injury happens extrinsically from the outside and tissue factor leaks into the blood from the cells outside these blood vessels. This initiates the formation of prothrombinase. In the intrinsic pathway, this is more complex and occurs much more slowly, taking several minutes. In this pathway, activators are in direct contact with the blood or contained within the blood. Outside tissue damage is not needed for the intrinsic pathway to begin. Prothrombinase is also formed, but after several reactions. This figure shows the difference between the extrinsic and intrinsic pathways. The extrinsic pathway has tissue trauma coming from the blood vessel from the outside. Because the blood vessel damage comes from the outside, such as getting an injury, a cut, etc., tissue factor is going to leak in, and this causes the process to happen much faster. In the intrinsic pathway, the trauma happens from within the blood vessel itself. So there's an injury or something that happens within that blood vessel instead of from the outside. Because blood flows through the vessels all the time, all day, there are little injuries that can happen within the blood vessel itself. Because the injury is on the inside, this process is going to take longer to start. As you can see in this pathway, there's many more activation processes that need to happen. However, whether it's in the extrinsic pathway or the intrinsic pathway, they both end in the formation of prothrombinase, which leads into the common pathway for both. The extrinsic pathway just gets there much more quickly. The beginning of the common pathway is marked by the formation of prothrombinase. Once prothrombinase is made, prothrombinase and calcium can catalyze the conversion of prothrombin to thrombin. One thing to note is that when you see a protein that has a pro in front of it, that means it's unactivated or inactive. It needs to be activated. So once it gets activated through a cleavage process, then the pro comes off and it is now in its active form. So prothrombinase is made, then with prothrombinase and calcium together, that's going to catalyze the conversion of prothrombin to now thrombin. Now thrombin is active and in the presence of calcium can convert fibrinogen to fibrin. Remember, fibrin is what we need in order to form that blood clot, and so fibrin is going to form the threads of the clot. At this point then, with those fibrin threads intertwined throughout that initial clot that we have formed, this is known as a fully formed blood clot. After the fully formed blood clot has been made, it is going to go through what is called clot retraction. Clot retraction is the consolidation or the tightening of the fibrin clot. As this clot contracts, pulls together tightly, fibrin attached to the vessel walls is going to also pull the vessel walls closer and closer together. This decreases further damage. This is going to hold everything in place, keep that vessel tight, and it's going to allow other cells to repair the damage that has happened underneath. Fibroblasts can come in and form new connective tissue, and then new endothelial cells can start to form to repair that vessel. The clot is going to stay in place until the entire area has been repaired by these other cells. once the entire area has been repaired after several days, etc., the clot will then eventually fall off. Even when there is no damage, blood clots can tend to form from time to time. Blood clotting is a positive feedback mechanism. Remember that positive feedback is where when something happens, it's going to keep going and going in the same direction and is amplified. So therefore, if a blood clot starts to form, it's going to start to activate more platelets and it can continue to grow bigger and bigger. So it has a tendency then to enlarge that clot and potentially block off blood flow through this undamaged vessel. But in our bodies, we have something in play called the fibrinolytic system. The fibrinolytic system is responsible for dissolving small, inappropriate clots that do happen from time to time. It is also responsible for dissolving clots at the site of damage that we just talked about. So once the repair has been finished, the blood clot has stayed there for enough time to allow the injured site to repair, the fibrinolytic system can help to dissolve that clot. The fibrinolytic system is composed of plasminogen. Plasminogen is an inactive plasma enzyme, which is actually incorporated into a clot when a clot is formed. When the repair has finished and plasminogen is activated into plasmin, then plasmin can dissolve the clot by digesting those fibrin threads. Once the clot is dissolved, then the pieces can be eaten up by macrophages in this area. The fibrinolytic system can also help dissolve those small inappropriate clots that can form within the blood vessels. And they do so by activating plasminogen into plasmin and helping to dissolve those clots so that they do not end up where they shouldn't. Now, if this system doesn't come into play like it should, then that will allow that clot to flow through the blood vessel and can lead to heart attack or stroke depending on where it falls. Sometimes it makes no issue whatsoever, but depending on where it goes, it can lead to other issues. Unfortunately, some people have issues with clotting factors in their blood, and their blood does not clot like it should. And so therefore, there are tendencies in that case when they get an injury or a cut, they can bleed out because the body is not clotting. So when you get in an injury and your blood starts to flow out and that you hold that injury with some pressure and that blood clot starts to form, that is your body's mechanism, your body's way of helping you not to bleed out. Obviously, if the injury is very large, then that becomes much more of an issue, and things like stitches need to be involved in order to help the body tightly form that clot. Thank you so much for watching my video. This was really just an overview of what a blood clot is, how it's formed, and then how it can be dissolved. There's obviously a lot more that can go into this. In the future, I'll make some more specific type of videos. If you have any questions, make sure that you put them down in the comments below. If you have an idea for another video, let me know that also. This is an educational and informational video, and it is in no way to be used as a diagnosis. This video is to help you better understand how the body works and how things can go wrong and why. If you haven't already, please make sure to subscribe to my channel and click on that notification bell so that you never miss out on a new video. Thank you.